Hello students, today we are going to start with the chapter Polynomials, which happens to be the second chapter of your NCERT textbook, and this happens to be the syllabus for the month of April also. Right, so to begin with, we'll start with the definition of the polynomial. So any expression of the form px is equal to a0 plus a1x plus a2x square plus a3x cube plus so on plus a n minus 1 x to the power n minus 1 plus a n x to the power n is called a polynomial. So certain things we need to know about this polynomial, and that is here. This a0 plus a1x, a2x square, etc. are called the terms of the polynomial. Point number 2, a1, a2, a3, etc. are the coefficients of the terms of the polynomial. Point number 3, the highest degree of this polynomial is n. Therefore, the degree of the polynomial px is n, provided a n is not equal to 0. And children, this is very important. Until and unless the coefficient of the highest degree is non-zero, we cannot say that the degree of the polynomial is n. Right? What will happen if n is equal to 0? Then the next highest degree is x to the power n minus 1. In that case, the degree of the polynomial becomes n minus 1. So whenever you say that the degree of a polynomial is n, that means its coefficient must be non-zero. Now next in continuation to this is types of polynomials. Now the polynomials are characterized by the degree of the given polynomial. If the degree of the polynomial is 1, then it is called a linear polynomial. If the degree of the polynomial is 2, then it is called a quadratic polynomial. If the degree of the polynomial is 3, then it is called a cubic polynomial. If the degree of the polynomial is 4, then it is called a biquadratic polynomial. Okay, now next. In what way these polynomials are represented? So the next topic is representation of different types of polynomials. Linear form polynomial. Children, these are all what you have done in class 9. This is just a recapitulation. So a real topic of class 10 is in continuation of this. Okay. So the general form of the linear polynomial is px is equal to ax plus b. Here the degree of x is 1, and that is why it is a linear polynomial. For example, you can write px is equal to 2x plus 3 or fx is equal to x, etc. are linear polynomial. Now its geometrical interpretation means when you draw the graph of this polynomial, you will always get a straight line. Come to the next polynomial, that is quadratic polynomial. Its general form is ax square plus bx plus c. Examples: fx is equal to 2x square plus 3x plus 5, or px is equal to 5x square plus 3, or gx is equal to x square. This doesn't mean that a quadratic polynomial always will contain 3 terms. It can have 1 term, it can have 2 terms, it can have 3 terms. Only thing you have to remember is that the degree of that polynomial must be 2. Now its geometrical interpretation is a parabola. That means when you draw the graph of this polynomial, you will always get a parabola. Now come to the next topic, and that is cubic polynomial. Its general form is px is equal to ax cube plus bx square plus cx plus d. Examples: px is equal to x cube plus 5x square plus 6x plus 8, or px is equal to x cube plus 5x square, or fx is equal to 5x cube plus 3. Here also it's not important that on the cubic polynomial must have 4 terms. It can have 3 terms, it can have 2 terms, as well as it can have 1 term. Okay. Now next is biquadratic polynomial. Its general form is ax to the power 4 plus bx cube plus cx square plus dx plus e. Example, fx is equal to 5x to the power 4 plus x cube plus 2x square plus 3x plus 7, or x to the power 4 plus 8x plus 27, etc. Now, next in continuation is the zeros of a polynomial, and this is a very important topic. You have already learned, and you should always remember this. Zeros, or in other words, it can also be termed as roots of a polynomial. Now, what does it mean? A real number alpha is said to be, or is called a zero of the polynomial if p of alpha is equal to 0. Right? Now, how to find the zeros of the polynomial? Simple rule it says is that equate the given polynomial to 0. For example, px is equal to 2x plus 5. Equating px to 0, that is px is equal to 0, this implies that 2x plus 5 equal to 0 implies x is equal to minus 5 by 2. So this minus 5 by 2 is the zero of the linear polynomial. Second example. Here px is x square minus 5x plus 6, means it is a quadratic polynomial. Remember children, the degree tells you how many zeros it will have. If it is a linear polynomial, you will get 1 0. If it is a quadratic polynomial, you will get 2 zeros. If it is a cubic polynomial, you will get at the most 3 real zeros. Like that it goes on. Right? So if this is the question, of course the basic rule is that equate the polynomial to 0. Therefore x square minus 5x plus 6 is equal to 0. Factorize this. You know how to factorize it. You have already done this factorization in lower classes, that is by middle term splitting. So this is x minus 2 into x minus 3. After factorization, you will get x minus 2 into x minus 3 is equal to 0. This implies that either x is 2 or x is equal to 3. Therefore, 2 and 3 are the zeros of the quadratic polynomial. The next example is if the polynomial is a cubic polynomial. Fx is equal to x cube minus 6x square plus 11x minus 6. So to find out the 0, again we will equate fx to 0. That is x cube minus 6x square plus 11x minus 6 is equal to 0. You factorize this, and you know how to factorize using hit and trial method. So after factorization, you will get x minus 1 into x minus 2 into x minus 3 is equal to 0. So this implies that the value of x is either 1, 2 or 3. That is, the zeros are 1, 2 and 3. So if the polynomial is a linear polynomial, we will get 1 0. If the polynomial is a quadratic polynomial, then we get 2 zeros, and if the polynomial is a cubic polynomial, you will get 3 zeros. Right? Now next topic is, if the zeros are given, then how to find out the polynomials? It is just the reverse case of what we have done earlier. There polynomial was given and zeros have to be found. Here, if the zeros are given, then how to find out the polynomial? Suppose x is equal to 2 is the zero of a polynomial fx. Then fx will be equal to x minus 2, and this x minus 2 is the polynomial. Next example, if x is equal to minus 5 is the 0, then fx is equal to x plus 5 is the polynomial. These are the examples if only 1 0 is given. Now next, if 2 zeros of a polynomial are given, then the quadratic polynomial is given by the formula px is equal to k times x square minus the sum of the zeros into x plus product of the zeros, and here k is any real number. The sum of the zeros means whatever zeros you have been given, that you add and take its product, and together you will get the polynomial. For example, if 3 and 5 are the zeros of the polynomial, then the quadratic polynomial is px is equal to k times this x square minus sum of the zeros is given, and sum of the zeros is here is 3 plus 5 whole into x, plus product of the zeros is given, so plus 3 into 5. Therefore, the polynomial is k times x square minus 8x plus 15. Right. Now, next example is if 3 zeros are given, then the cubic polynomial is given by px is equal to k times x cube minus sum of the zeros into x square plus sum of the product of the zeros taken 2 at a time whole into x minus product of the zeros. For example, if the zeros are 1, 2 and 3, then px is equal to k times x cube minus the sum of the zeros is given, so you will add 1 plus 2 plus 3, that is 1 plus 2 plus 3 whole into x square plus, now what does it mean? Sum of the product of the zeros taken 2 at a time. Here the zeros are 1, 2 and 3. Therefore, 2 at a time, how will you take? 1, 2, then 2, 3 and then 3 and 1. So, you have to form the product and take its sum. So, 1 into 2 plus 2 into 3 plus 3 into 1 whole into x minus the product of the zeros, that is 1 into 2 into 3. So, you will get the polynomial as k times x cube. The sum is minus 6x square. And here it is 2 plus 6, 8, 8 plus 3, 11. So, plus 11x minus 6. Now, the next topic is relation between the zeros and the coefficient of a quadratic polynomial. Here we will straight away start with the question, and then we will generalize the result. Now, find the zeros of the polynomial px is equal to x square plus 7x plus 12 and verify the relation between its zeros and its coefficient. Now, the polynomial is what? Px is equal to x square plus 7x plus 12. To find the 0, you will equate px to 0, and x square plus 7x plus 12 is equal to 0. Factorize it by using middle term splitting. So, you will get x plus 3 into x plus 4, that is equal to 0. This concept you have already done. So, this implies that x is equal to minus 3 or minus 4. Right. Therefore, the zeros are minus 4 and minus 3. You need to find out the sum of these zeros. So, sum of the zeros will be what? Minus 4 plus of minus 3, that is equal to minus 7. Now, certain arrangement we have to do here. This minus 7 will be written as minus of 7 by 1. Why this arrangement? Because here the 7 is the coefficient of x and it is positive. So, this is positive here. Upon 1 means 1 is the coefficient of x square. So, minus, you may write it as coefficient of x upon coefficient of x square. Right. Now, let us see what happens with the product of the zeros. So, product of the zeros will be minus 4 into minus 3, that is equal to 12. Again, 12 can be written as 12 by 1. Why this 12 by 1? Here, go back to the polynomial. 12 is what? 12 is the constant, and again 1 is what? The coefficient of x square. So, this will be written as constant of the polynomial upon coefficient of x square. Therefore, in general, if fx is equal to ax square plus bx plus c is a quadratic polynomial, then the sum of the zeros is always equal to minus b by a, where minus b by a, where b is what? The coefficient of x, and a is what? The coefficient of x square. So, thus we have arrived at a relation between the zeros and the coefficient. Sum of the zeros will be minus b by a, and similarly product of the zeros is c by dot. Now, next example, fx is equal to x square minus 2. Here the term containing x is absent, so we will rearrange it and write x square minus 0x minus 2. So, to find out the 0, you will equate fx to 0, that is x square minus 0x minus 2 equal to 0, or x square minus 2 equal to 0. So this implies that x is equal to plus minus root 2. That is, root 2 and minus root 2 are the zeros, right? Now we'll find out the sum of the zeros. Sum of the zeros is equal to minus root 2 plus root 2, and that is equal to 0. And this 0 is nothing but the coefficient of x here in the polynomial. So that is equal to 0 by 1, and hence it is minus of coefficient of x upon coefficient of x square. This 0 can be written as minus 0. It doesn't matter, right? Okay. Now product of the zeros will be minus root 2 into root 2, that is equal to minus 2, and minus 2 can be written as minus 2 by 1, and again minus 2 is what? The constant, and 1 is what? The coefficient of x square. So this was the example of quadratic polynomial. Now we'll go back next question example, and that is if the polynomial is a cubic polynomial. Suppose fx is equal to x cube minus 10x square plus 31x minus 30. Again, to find out the zeros, you will equate fx to 0. That means x cube minus 10x square plus 31x minus 30 is equal to 0, right? Factorize it using the hit and trial method. So you will get x minus 2 into x minus 3 into x minus 5 equal to 0. So this implies that the values of x are either 2, 3 or 5. That is, the zeros of the polynomial are 2, 3 and 5. Now we'll see what happens with the sum of the zeros. Sum of the zeros is 2 plus 3 plus 5, right? This 2, 3 and 5, add it, you will get 5 plus 3, 8 plus 2, 10, 10. And this 10 can be written as 10 by 1. And you have to rearrange it because the coefficient of x square is minus 10 here. So this plus 10 will be written as minus of minus 10 upon 1. So this is equal to minus of coefficient of x square upon coefficient of x cube. Now here next factor is sum of the product of zeros taken 2 at a time. So how will you take 2 at a time? Earlier also I have explained 2, 3, then 3, 5 and 5, 2. So 2 into 3 plus 3 into 5 plus 2 into 5, and that comes out to be 31. Now again 31 is written as 31 by 1. Children, why I am writing it as 31 by 1? Because the coefficient of x cube is 1. Sometimes in some question the coefficient of x cube is 2. In that you have to rearrange it in suppose if it is 31 and the coefficient of x cube is 2. So you cannot write it as 31 by 2. You have to write it as 62 by 2. Right? So 31 by 1, and that is equal to coefficient of x upon coefficient of x cube. And next is the product of the zeros. Multiply all these zeros, so you will get 30, and again here the constant is minus 30. You will rearrange it as minus of minus 30, and that is equal to minus constant upon coefficient of x cube. So how will you summarize it? If fx is a quadratic polynomial, then the sum of the zeros is minus b by a and product of the zeros is c by a. A, b and c has got their usual meaning. What is a? The coefficient of x square. What is b? The coefficient of x, and c is the constant term. Now next is if fx is a cubic polynomial. In that case the sum of the zeros is minus b by a. Sum of the product of zeros taken 2 at a time is c by a, and product of the zeros is minus d by a.